You may not have realized this, but artificial intelligence is already very much a part of your life. Artificial intelligence or AI lives in your smartphone. For example, it drives Apple's Siri technology that allows you to interact with your phone using natural language. It is present in the recommendation systems of websites like Amazon that suggest to you what you might like. And soon it will impact many more areas. Many tasks being performed by humans today will be better done by AI machines, and in the coming decades, this will change the very nature of employment. Just like you may not know how your smartphone works technically, but you know how to make the most of it for your work and for your convenience, likewise, since AI is becoming an integral part of your life, it is better you understand it and learn how to use it optimally so that in future that is emerging, instead of competing with it for jobs, you use AI to complement your skills. AI is a computer that learns by itself. It does so by using machine learning, which is different from traditional rule-based programming and uses computers' ability to analyze big amounts of data and decipher patterns from it. Pedro Domingos, the author of the book The Master Algorithm, explains that traditional programming involved inputting data and an algorithm. An algorithm is a detailed sequence of steps or operations that tells the computer what to do with the data. The computer then processes the data based on the algorithm and outputs the result. As against this, in machine learning, very large data sets are input along with samples of the desired output, and the computer generates the algorithm itself. For example, we input millions of X-ray images of lungs into a computer, and for a few thousands of these X-ray images, we tell the computer which X-ray images reveal cancer and which portray a normal lung. The computer then analyzes these X-ray images and teaches itself how to detect cancer. If the computer makes a mistake in its diagnosis, this data is again fed back, and this process is repeated. By this iterative process, the computer continuously enhances its self-created cancer detection algorithm. Professor Domingos explains that there are different approaches to machine learning. Some computer scientists take inspiration from the first-order logic to derive the AI algorithm. In this method, specific facts are input and the computer itself discovers the general principle hidden in these facts. This approach, for example, is used in drug discovery, like finding a new drug for malaria. Another group of computer scientists take inspiration from the way the brain and the neurons work to create neural networks. Just like our brain receives input from the sensory organs and finds patterns in this data, in a similar manner, this AI process extracts rules and patterns from a set of data. This AI approach, also called deep learning, for example, is used by Facebook's deep face facial recognition system, which identifies human faces in digital images. It has 9-layered neural network, and to train itself, it used 4 million images uploaded by Facebook users. In another AI approach, uncertainty decides the probability of different possible outcomes, and based on actual outcomes, this probability is updated and iteratively the system performance improves. This AI approach is used, for example, in email spam filtering and in Google's self-driving cars. Another AI approach takes inspiration from reasoning by analogy and uses what is called the nearest neighbor algorithm. Recommendation systems, if you like this song you may also like, and collaborative filtering use this approach. There are two types of AI. Weak or narrow AI are systems that can solve specific, reasonably well-defined problems. In 1997, IBM's Deep Blue computer beat the then world chess champion Garry Kasparov. In 2011, IBM's Watson computer beat the human champions of the American television game show Jeopardy! In 2016, Google's AlphaGo AI machine beat the world champion of Go, a really complex strategy board game. These and other examples like spam filtering and recommendation systems are all examples of weak AI. IBM's Deep Blue computer was very good at learning and improving its chess playing technique, but it was not much good at anything else, not even at playing other games. Strong or artificial general intelligence is, as yet, a hypothetical machine that can think, learn, and perform any intellectual task that a human being can perform. Strong AI can improve its performance by using what is called recursive self-improvement. natural language processing, and computer vision are examples of strong AI. Some computer scientists believe that sometime in the future, not certain when, there will be a moment of technological singularity when AI will exceed human intelligence. We could also come to a point where AI machines will create even more intelligent machines themselves, what is described as artificial superintelligence. Although when this will happen is not certain, many prominent people like Bill Gates, Elon Musk, and Stephen Hawking are of the view that we need to put safeguards in place because the maker of these machines, us humans, will no longer be in charge of such machines. Swedish philosopher Nick Bostrom believes that artificial superintelligence poses existential risk, meaning such machines pose the danger of annihilating humans. Whether in the long run strong AI poses an existential threat or not, what is certain is that in the shorter term, weak AI itself is disrupting our socio-economic future. Some experts argue that AI will lead to mass unemployment, leading to massive social unrest, while other experts are of the opinion that adoption of AI will lead to emergence of new, highly creative jobs. We don't know which of these prognoses will come true, but one thing is certain: the skills, competencies, and dispositions needed to flourish in the age of intelligent machines is fast becoming very much more than mere acquisition of knowledge. Creativity, ideation, large frame pattern recognition, ability to solve unstructured complex problems, fine dexterity, and multisensory communications, along with the ability to complement these skills with the use of AI, such that the human machine alchemy allows you to do tasks that were not possible earlier, like creating new products and offering novel services, will greatly enhance your employability and entrepreneurial potential.